Hello everyone and welcome to this video on the TTL Tottem configuration. This is a series of videos. This is the course, another course of digital design. This is a classroom discussion number 5. And in this video, I will be discussing on the output configuration. What are the different output configurations? And majorly, I will be concentrating on two output configuration: total value output configuration and open collector output configuration. So basically, there are three output configurations in your TTL circuits. First one is totem pole output configuration. Number two is open collector output configuration. And the third one is tri-state output configuration. So out of this one, first once you go for the output configuration of totem pole output configuration, this output configuration has a very good advantage over here in this circuit. Totem pole or pull-up circuit will say this one. Why we will say it is a pull-up and why it is said to be a totem pole configuration. So the totem pole configuration is said as Q3 and Q4. These are the two output transistors, and this will be such a way that when Q3 is off, Q4 is on, and when Q4 is on, Q3 is off. So vice versa would be taken into consideration, and that's the reason it is called as totem pole configuration. The other way why it is called as pull-up, that will be discussed right now. Already you are known that there are two. This is an TTL 9 gate. We have discussed the configuration of this one and how the working of this one will be taking place. So when both the inputs are low or any one of the input is low, then this transistor Q2 is off. Okay, this is a collector, so the total current from the base of the collector is base of the transistor Q2 is moved through the collector and it is passed over. So there is no current at the base of this transistor Q2 and this transistor Q2 is off. When transistor Q2 is off, at the same time the transistor Q4 is also off. Why? Now from the emitter there is no current. This is off. So certainly this Q4 is off. But as this is circuit is being cut off, total current will be flowing to the base of this transistor Q3 and Q3 is on. So this case, when Q4 is off, Q3 is on. And next case, when both the emitters are high, then what happens is that base emitter junction is reverse bias and collector base junction is forward bias. This is the peculiar case when emitter behaves as a collector, collector behaves as an emitter. And so there would be a current flowing which is equal to the sum of these two currents. The collector current and the base current would be flowing into this one, and this transistor Q2 is on. And when this transistor Q2 is on, it would be flowing and Q4 would be on. So this Q4 is on means um, when Q4 is on, what happens is that whatever the current is that it very less current will be flowing to the base of this transistor Q3 and with a zero voltage, and all the voltage would be going to the drain over this one. So when Q4 is conducting, the voltage and the output will be what? Zero. And this transistor Q3 is off, and so here whatever the voltage is there, this voltage won't be sufficient to drive this base emitter voltage and diode. That's the reason this transistor is off. Basically here you would be having a voltage which is equal to around 0.9 something like that, but wait with that. So we are not going in detail about the conceptual one. So here Q3 is off, Q4 is on, Q3. So this is called as a totem configuration. The next thing over here is that what is the advantage of this circuit is that, so in this circuit usually when the transistor is Q4 is off, the output should charge from 0 to VCC. So when the output is getting charged from 0 to VCC, you require it will charge with a time constant now is equal to RC. So whatever the load capacitance, if we consider the load capacitance C, so we won't change the load capacitance. Only the thing is that resistance has to be changed. So we'll be keeping a very low resistance over here, and this transistor, when it is conducting, it is having a zero resistance. So this would be charging from 0 to VCC. This is called as an and the same time when transistor transistor Q4 is on, if at all a heavy current flows over there, then this transistor may get damaged over there. So what happens over there is one is that if there won't be any current flowing through this circuit, it will be zero current by this transistor getting off. When this is off, there is an open switch, zero negligible current will flow into the base of this or to the collector of this transistor Q4 and the circuit to serve even to the load of that. So this is an overall configuration of totem pole which has been very much useful, and this configuration is used in the 7-port series of TTL gates. So mostly in our labs we are having this 7-port series of TTL gates that you can check it up in it. And another configuration, output configuration, is TTL open collector. In this configuration, the output is collector is open. You say the output is taken from the open at the output of the collector. So this you doesn't have an pull up circuit which is there in your uh, configuration. This circuit is being moved and directly it is taken open. So when you go for this one, the same thing. When transistor is on, then Q2 is on, Q4 is also on. Output is equal to saturation voltage. When QT is off, Q4 is off, and the output is equal to VCC, which is taken from this. So the thing is that the circuit working would be the same thing over here. Very simple. Output is taken from the collector of the output gate, output transistor. Then this is called as an open collector on. So the open collector output configuration of TTL is similar like your totem pole configuration. Only the thing is that pull-up circuit is not there. Pull-up circuit has been eliminated. So instead of this pull-up circuit, what we are having, we are putting in a resistor. When they say external pull-up resistor is an, and using of this TTL, we will be having before we close it up, we'll see some of the advantages of TTL circuits. So TTL circuits are very high speed operation would be there, and their propagation delay is around 10 milliseconds, which is fast when compared to your DTL and RTL logic gates. It has a low power dissipation compared to DTL and RTL, low cost and better fan out, and it is reliable operation for mass one. These are the advantages of your DTL circuit. Thank you for watching this video.